What is a physical change? A physical change is one that alters the form of a substance but does not result in the formation of new substances. The mixing of iron with sulfur and the dissolving of salt or sugar in water are examples of physical changes. In a physical change, no chemical reaction occurs. No new substances are formed. The changes that take place can be easily reversed. What are chemical changes? A chemical change is usually called a chemical reaction. A chemical change is one that forms one or more new substances. The rusting of iron nails and the decomposition of substances are examples of chemical changes. In a chemical change, a chemical reaction occurs. One or more new substances are formed. The changes that take place are usually difficult to reverse. Very fast reactions. Formation of lead iodide from the reaction of aqueous lead nitrate and potassium iodide. Explosive reaction of hydrogen-oxygen mixture. Burning airship due to the hydrogen-oxygen reaction. Moderately fast reactions. Reaction of zinc metal with dilute acids. Concentration of the reactants. Reaction of carbonates with dilute acids. Browning of cut fruit. Browning of cut apple. Many factors affect the rate of a chemical reaction. Slow reactions. Fermentation of grapes to form alcohol. Rusting of iron in air. Weathering of stone structures. Factors affecting the rate of reaction. Pressure of the gaseous reactants. Temperature at which the reaction is occurring. Catalysts. Surface area of solid reactants. Concentration of reactants. The collision theory. The collision theory states that for a reaction to occur, the reactant particles must collide with each other. Must collide with energy that is equal to or greater than the activation energy. When the collisions between reactant particles fulfill these two conditions, product particles are formed. These collisions are known as effective collisions. The frequency of effective collisions between reactant particles affects the rate of reaction. An increase in the frequency of effective collisions increases the rate of reaction. How does concentration of reactants affect the rate of reaction? When the concentration of a reactant is increased, the rate of the reaction increases. At a lower concentration, the reactant particles are spread far apart. At a higher concentration, there are more reactant particles in the same volume. At higher concentrations, there are more reactant particles available to collide with each other. This means that the collisions between the reactant particles become more frequent. As a result, the frequency of effective collisions increases and the rate of reaction is higher. How does pressure of gaseous reactants affect the rate of reaction? When the pressure of a gaseous reactant is increased, the rate of reaction increases. At lower pressures, the particles of gaseous reactants are spread far apart. At higher pressures, the particles of gaseous reactants are closer together. Thus, at higher pressures, the collisions between the particles of gaseous reactants become more frequent. As a result, the frequency of effective collisions increases and the rate of reaction is higher. How does the surface area of solid reactants affect the rate of reaction? If a solid reactant is broken up into smaller pieces, its total surface area increases. There are more surfaces that are exposed for collisions to occur. Only the surface of a solid reactant is exposed to collisions with the particles of other reactants. Thus, the smaller the particles, the greater the surface area and the higher the rate of reaction. When a solid reactant particle is broken up into smaller pieces, the smaller pieces have a larger surface area than the original solid reactant. Thus, when the particle size is decreased, the total surface area is increased. The frequency of effective collisions increases. The rate of reaction increases. How does temperature affect the rate of reaction? When the temperature of a reactant is increased, the rate of reaction increases. At low temperatures, the reactant particles move slowly because they have little energy. When the temperature is increased, the reactant particles gain kinetic energy. As a result, the particles move faster and collide with each other more often. At higher temperatures, more particles possess energy equal to or greater than the activation energy, resulting in a higher frequency of effective collisions. Thus, the rate of reaction is higher. How do catalysts affect the rate of reaction? Activation energy is the minimum energy that colliding particles must have to react. It is an energy barrier that must be overcome by the reactants before they can react. Catalysts increase the rate of reaction by providing an alternative pathway for the reaction to proceed. The catalyst reaction has a lower activation energy than the reaction without the catalyst. The activation energy of the catalyst reaction is lower than that of the uncatalyzed reaction. For the catalyst reaction, where the activation energy is lower, more colliding particles possess energy equal to or greater than the activation energy. The frequency of effective collisions increases, resulting in a higher rate of formation of product particles. Thus, the rate of the catalyst reaction is higher.